Welcome to aminacademy.com. In quantum mechanics, let us discuss about de Broglie relation. The de Broglie equation states that matter can act as waves much like light and radiation, which also behave as a waves and particle. That is the duality nature of the radiation, right? The equation further explains that a beam of electrons can also be diffracted just like a beam of light. In a sense, the de Broglie's equation helps us understand the idea of matter having a wavelength. Therefore, if you look at every moving particle, whatever it is microscopic or macroscopic, it will have a wavelength. In cases of macroscopic objects, the wave nature of matter can be detected or it is visible. What is de Broglie equation? The de Broglie equation is one of the equations that is commonly used to determine the wave properties of matter. It basically describes the wave nature of the electron. The electromagnetic radiation exhibits the dual nature of a particle having a momentum and wave expressed in frequency and wavelength. Macroscopic particles like electrons also Microscopic particles like electrons also proved to possess this dual nature property. Louis de Broglie in this thesis suggested that any moving particles, whether microscopic or macroscopic, will be associated with a wave character. It is called matter waves. He further proposed a relation between the velocity and momentum of a particle with the wavelength if the particles had to behave as waves. The particles and wave nature of matter, however, look contradictory as was not possible to prove the existence of both properties in any single experiment. This is because of the fact that every experiment is normally based on some principles and results related to the principles are only reflected in that experiment and not the other. Nonetheless, both properties are necessary to understand or describe the matter completely. Hence, particles and wave nature of matter are actually complementary to each other. It is not necessary for both to be present at the same time. Though the significance of the de Broglie relation is that it is more useful to microscopic fundamental particles like electrons. Now we'll derive some de Broglie relation. De Broglie relation states that all moving particles have an associated wavelength described by the equation, that is h equal to lambda equal to h by p, where lambda is wavelength, h is the Planck's constant, that is 6.626 in 10 raised to minus 34 joules per second, and p is the particle's momentum, that is p equal to mv. That is, we write the relation here first. Lambda equal to h by p, that is equal, further you can say lambda equal h by p is already mv. Where lambda is the wavelength, h is a Planck's constant, or m equal to mass, and v equal to velocity of the particle. The de Broglie's relation, the core idea proposed by Louis de Broglie, the relation suggests that just as light can behave as both a wave and a particle, so can all matter. The formula, the relationship between a particle's wavelength and its momentum is expressed as lambda equal to h by p. Lambda equal to h by p. Since momentum p is mass and velocity, the formula can be written as lambda equal to h by mv. Some implications. The formula shows that wavelength is inversely proportional to the momentum. This means that as a particle mass or velocity increases, its wavelength decreases, making it more particle-like and waves properties less apparent. Experimental verification. Davisson-Germer experiment. In 1927, Davison and Germer observed that electrons scattered off a nickel crystal produced a diffraction pattern similar to what X-ray produced. Key observation: the intensity of the scattered electrons varied with the scattering angle, with a peak intensity at a specific angle that depends on the electron's kinetic energy. Some confirmation. This diffraction pattern was a definitive proof that electrons, which were previously thought of as a particle, also exhibit wave-like behavior, confirming de Broglie's hypothesis. So far, we discussed about de Broglie's relation in quantum mechanics. We have done. Please subscribe our YouTube channel.